Hey guys, and welcome to another episode. In today's video, I'm going to show you how to completely disassemble a short block. So what that means is I'm going to be taking apart everything that's found below the head gasket. So if you guys saw in my previous video, I showed you how to disassemble a cylinder head. And the cylinder head and all those components are found above the head gasket. So once you unbolt the head from the block, this is what you have left. So once you take those studs out, you take the bolts out, you take the head out, you're going to have your head gasket, and then you're gonna have everything in your short block. So everything from your crankshaft to your pistons to your connecting rods and all the other bearings, that is all found below here. So we're first gonna begin by turning the entire short block upside down, and we're gonna start working from there. So we're first gonna begin by turning the engine upside down. So we're gonna take this pin out, we're gonna turn this 180 degrees, and then we're gonna reinstall that pin through here. And it's going to keep it so that the engine is not going to rotate or spin on us. Now we're going to begin removing the oil pump from the bottom assembly of the crank.
To get to the internals of the engine, this oil pump needs to be removed. With the pump exposed, we can see there is a black plastic cover. That needs to be pried off, which will expose a Torx bolt that is securing a cog to the oil pump. It doesn't have to be removed. However, if you want to remove the oil pump without disassembling the engine, you'd have to pull this gear from the pump. Next up comes removing the 3 Torx bolts that are securing the oil pump up to the block. So there's going to be each one of these that are going to be securing it down in place. Now they are going to be somewhat tight. However, if you use a 1/2-inch ratchet, you'll be able to get enough torque to break these bolts loose. Almost every oil pump is going to be the same design where it's chain driven, so that should the engine turn off, you're still going to have a mechanical function that's going to be turning the oil pump and ensuring that everything is lubricated properly. So by doing the same procedure, you can remove the oil pump from your engine. So once you have each one of those bolts removed, you should be able to lift up on the oil pump and move the crankshaft sprocket that's attached to the chain out of the way, and then lift the entire thing up and out.
Okay, so good news, the oil pump is now removed along with the chain and the cog that's found on the front side of the engine. Now, I've got some bad news for you guys. Check this out. So if you can see over here, we've got the oil pump, and as I lifted it up, I saw this little piece right here. Now, what this is a piece of the timing chain guide. Now, I'm not entirely sure where it's from, because everything in the oil pump is mechanical, but this is made of the same material as the timing chain guide. I'm gonna go take a look at my old piece to see if there's any part that this came off of.
So I went to go ahead and inspect both the upper and the lower timing chain guides that I removed from the car. So as I removed the entire timing set from the engine, I had all these extra pieces aside. So this lower timing chain guide is the part that guides the timing chain when it comes from the crankshaft and goes up to the camshafts. You can see that this is a darker, more oil-stained piece of plastic, and this color is a perfect match to the extra piece that I found on the oil pump. Now, when I went to go look at the upper timing chain guide, I noticed that it wasn't the exact same color. I noticed that it was a much lighter colored yellow, and it looked like it was less oil-stained. So I did indeed realize where this little extra piece came from. And you guys probably have a guess too. It's from the upper part, and I'll show you exactly how I found that out.
So I found out where this came from. So the timing chain guide was replaced at some point because, oops, that little piece of plastic that I found is a piece that goes right here. So it was from an older piece that broke off. So that means that the timing chain on my car was replaced at some point. So that's probably why I didn't see anything else damaged here. So these look to be okay, but that one there is not. This old piece that I found inside the oil pump seems to be the same color as this. So I'm guessing the top piece broke off when this engine was working or whatever. It broke off, and the person that had this car only replaced this top piece. Now, because of that, this one here seemed fine, and maybe that's why they sold the car. I don't know, but it definitely is not of the same age and newness as this piece. So that's where it came from because it sits on there, but that's no big deal because, well, we have this all apart. Now I'm going to be setting all this aside, and I'm going to be putting new pieces in to replace this guy and this guy. When you replace your timing chain along with your guides, you're going to be replacing this piece here, this chain, along with the other chain that's found and connecting the crankshaft up to both camshafts. So that's going to be for another video, but I just wanted to show you guys that I found a piece. That's no good. Well, it's good that I found it. It's bad that it's there. Anyways, we're going to go back to the motor and continue working on that.
With the oil pump out of the way, we can see that there's this black cover that needs to be removed. There's going to be 4 bolts that are going to be securing it up to the lower part of the block. With it removed, it's going to give us access to the bolts that are securing the connecting rods up to the crankshaft.
Next up comes removing the crankshaft, and the crankshaft is found down in here. So it's secured up to the block, in between the block and between this top part. And it's basically getting sandwiched in between both of those two pieces of metal. So in order to take that off so we can get access to both the pistons, the connecting rods, and all that stuff, we need to remove the bolts that are found on the perimeter of the block. So there's going to be a total of 18 of them, and they're all 8 mils. So once you have each of those removed, you can then set those aside, and then we're going to be able to get access to these bolts right here, found up top for the main caps, and then we'll be able to take it all out.
So first comes first with cracking each and every one of these 18 bolts loose. So the tops of each one of these bolts is an 8mm, so you can use either an open-ended wrench or a ratcheting wrench to get that done. Once they're loose, you can grab an impact driver or just some other way of removing them. Now I'm going to be using my DeWalt impact driver because it's going to be a little bit faster than removing all of them by hand. Next up comes removing the connecting rod bolts that are secured up to the crankshaft. So you can see with the position of the crankshaft, we can't exactly see those bolts. So if we move to the clutch side of the engine, we're going to see that we have the tone ring for the crankshaft, and you can turn that and it'll give us access to those bolts. So I'm going to begin by removing the piston that's furthest away from the tone ring. Each one of the connecting rod caps is held in place by 2 Torx bolts. So by using a 1/2-inch driver and the appropriate Torx socket, you can remove each of these. Pay attention when you're taking these out because there's going to be a bearing cap that's going to be attached to the crankshaft for each one of these connecting rods. Be sure to keep them all together and don't lose track of them. Using a set of needle nose pliers might come in handy in this tight little space. So once you have those out, you can then turn the crankshaft and you should then be able to remove the piston from the block. The piston, the connecting rod, the piston rings, and everything should come out all in one piece. So what we're going to do then is we're going to make sure that we have the entire connecting rod and the rod cap together in the proper way that it came out, and we're going to reinstall the 2 connecting rod bolts back into the connecting rod. We're then going to set that aside, and then we're going to go and work on the remaining 3 pistons and rods that are still found in the block. To work on every next piston and connecting rod, you're going to need to be able to turn the crankshaft. So it's quite simple. Go to the clutch side of the engine and just turn that tone ring until you can see both bolts. Staying organized while you're doing this process is key because if you have to ever replace any of these parts or put them back together in the engine, the reassembly process is going to be a lot easier. So just keep on doing this until you have all 4 of your pistons, your connecting rods, and everything removed. With each of the sets of pistons and connecting rods removed, we can inspect each of the bores of the engine to see if there's any damage, any irregularities, or anything that would be of a concern. I'm using a simple flashlight and it's going to do a very good job at showing any scratches, any marring, or any other imperfections. Since everything looks good, we can now flip the engine back upside down and then split the lower block from the upper block. That will then allow us to remove the crankshaft. There are a total of 10 main stud bolts. 8 of them are exposed when the oil pump is removed, and then there are an additional 2 that are nearly exposed to the elements. The 2 hidden bolts are covered by 2 little steel caps. I haven't been able to find out a way to remove these caps without physically destroying them. I first tried to drill into the top of them and then use a little prying pick to take them out, but they seem to be in there pretty good. So I said screw it and I took out a hammer along with a sharp punch. I began to strike one of the sides, which gave me a small opening. A little bit of oil came out from the hole, but it wasn't a big deal. However, I was then able to use a small pry bar in which I was able to lift the caps out of the block. I then repeated the exact same procedure to the second cap that was covering up the last bolt for our entire lower block. By using a punch and a hammer, you'll be able to make a slight hole on the side, and then you'll be able to stick a little pry bar or some other kind of tool to lift the entire thing up and out. There is no extractor or any kind of special tool to take these out without damaging them. We're going to have to replace these when we have to put the engine back together.
With the engine block now in this state, we have all 10 of the bolts now exposed. So you can see that we have the 2 that were covered, they're now exposed, along with the other remaining 8. Now, I'm not sure if you can actually get a replacement cover for those bolts, but you do indeed need to take them off in order to get access to these 2. If you can't take those covers off, you can't take those bolts out, and then you won't be able to separate this bottom part from the main part of the block. Now, if you can't do that, the crankshaft cannot come out. But it is going to be coming out. We're going to be replacing the bearings, and we're going to make all this look nice and clean once we're done. So with it like this, we can grab our 16 millimeter thin wall socket and take off each and every one of these bolts.
These main stud bolts are what are called torque to yield bolts. This design of mounting hardware is in the form of a fastener where torque is applied to the bolt to the point that the bolt deforms by stretching, which is causing it to be permanently elongated. There is no way to reuse a torque to yield bolt. Once it's been stretched, there is no reversing it. When they are stretched, they will not provide the same clamping force as before. Should you reuse one, instead of it behaving as a torque to yield bolt, where it will stretch, it will become a torque to fail bolt. In most engines, the main studs that we are removing here, along with the head studs and connecting rod bolts, are all torque to yield bolts, and they all should be replaced once you disassemble it. I'll be further addressing this during the reassembly of the engine, but for now, just remove these 10 main cap bolts and then set them aside. Following that comes separating the lower block from the upper block. Since everything is machined so perfectly, splitting them might be a tad tricky. It may also be silicone to prevent any leaks. To get around this, you can use a small pry bar to help split both components. There will be a few different locations around the perimeter where the pry bar will fit. Try to wiggle it a little bit at a time to prevent anything from warping or causing any other kind of damage for that matter. You will then be able to lift the entire lower block out, which is essentially all of the main caps all together in one piece, and then you can set the entire thing aside. We can now inspect the crankshaft along with the engine internals to determine if there is any damage or excessive wear.
On the side here, we have the rear main seal, and you can see that we have a 4-cylinder crankshaft found in this engine. So that's not really surprising at all. This came from a 4-cylinder Mini. Now we can see that we have 1, 2, 3, and 4 different journals for the connecting rods. We also have other journals found in between there, and these are what actually stay stationary, and the ones that are furthest from the center are the ones that move. See what I mean? Now, on top of that, this is what's called a flat plane crankshaft. Most 4-cylinders are like this. So all the journals are found in a straight line. So everything is up and down. On a cross plane crank, we're gonna have everything in a star. So we're gonna have the first one at the top, the second one down here, third on the bottom, fourth over here. An easy way to think about it is that the crankshaft, if it's at center, the only deviations that a flat plane crank has is either out or in. There are no crankshaft journals for the connecting rods up here that go up and down. So you're only gonna have it in and out, not in and out and up and down. So if you have a flat plane crank, it's going to be in this orientation. A cross plane crank is going to have out and in along with up and down. With the crankshaft like this, we can inspect each and every one of these journals. So you can see that we have these pins here for the oil to get into to lubricate the journals. We have that found here. If we turn the crankshaft, you can also see that there's them found here on these journals. We're going to have to remove the crankshaft from the block because we're going to be balancing both the crankshaft, the connecting rods that connect to here, and the pistons and the piston rings that go around each one of the pistons. We're going to be balancing each one of those assemblies to 1/10 of a gram, and that's going to assure that the entire assembly will be able to be spun at speeds of over 10,000 RPMs. So when this crankshaft is spinning super fast, nothing is going to be giving any weird vibrations, which could potentially lead to a failure. So by inspecting each one of these and replacing all the seals here, and the bearings that are found on each one of the journals, everything is going to be good to go.
With the engine block now split, you can grab a razor blade and just trim off any excess silicone that's found around the perimeter of the block. Following that, you should then be able to just lift the crankshaft right up and out. Now just take note of any other bearings that are attached to the connecting rod and also the ones that are found on the block. So these main bearings that you see right there, they need to be removed, and we are going to be replacing these things once we put everything back together. So you can see the groove in the center, and that's where the oil is fed to keep everything nicely lubricated. To remove them, just push them forward so they come up a little bit, and then take each one of them out. Now I'm keeping track of which one of them went where, so that should I need to reuse it, I can. You can now also remove the 2 thrust bearings that are found on the block. There's going to be 2 of them, one of them found on each side of this main bearing journal, and then you just can take them and set them aside. They're there to keep the crankshaft aligned forwards to backwards inside the block. go ahead and turn the engine on its side, and we're going to begin cleaning this thing. So you can use any kind of brake cleaner or carb cleaner that you want to remove most of the oil and hard-on dirt that's found in the block. Following that, you can remove the front main seal that's still attached to the block. Now I'm going to go ahead and use some Meguiar Super Degreaser and a hog hair brush to clean out the internals of the engine. Brake clean will do the job, it will get it done, but the degreaser will get an even better job if you follow it up. You can also use the exact same degreaser on the outside of the block. So since I'm going to be painting this thing up, I want to try and make this as clean as possible. I'm going to be making a separate video on just taking care of the outside of it because I want to paint this up and make it so that it looks really nice. I want the block along with the rest of the engine to not only work very well, but also to look very good. If I can spend that time to do it now while everything's out and apart, I'm going to be a happy camper. You can follow this up to remove any other water, dirt, or any other crud that's in there with an air compressor and a blowing attachment.
So off camera, I went ahead and did a little bit of work. So I noticed that, okay, there's the 4 cylinders for each one of the pistons. These here are galleries that are for the oil. Okay, so there's those 6. Okay, so let me first zoom in on these first 3. Okay, see those? Those aren't too bad. I clean those up and I use the exact same Dremel kit and the carbide bit to clean those up. These 3 I did not, however, clean up. It's kind of hard to see and focus on it, but you can see there's irregularities in the casting. Here, there isn't. Well, there was, but I cleaned them up. So you guys can go ahead and clean all this stuff up and it'll make it so that the oil will want to return into the bottom of the pan faster. So, well, considering the engine is upside down, once you spin it, any oil that's going to be found on the top is going to want to flow down. And if it's stuck and it gets caught on any kind of irregularity, or if the orifice is too small, the oil is going to take longer to get to the bottom of the oil pan. So if you clean those up and you use a carbide bit like this on your drill, you can clean those up and make them look nice.
So I want to show you the difference of what I did by shaving down the little bit of aluminum on here. So if I just showed you the time lapse straight, it's pretty difficult to tell. But if I take a shot from the beginning and a shot from the end, you'll be able to see how much metal I removed. Now I'm not taking off pounds of metal in here. All I'm doing is trying to shave down each one of these holes to make it a little bit smoother. So you can see by using this carbide bit, it cuts through the aluminum very easily and it leaves us nice results. The casting marks are no longer really that jagged. Now you can go ahead and do it even more, but for me this is good enough. Since I have the engine apart, I figured this would be a great time to do this.
The biggest difference that you're going to see though, if you want to do any kind of machining or grinding down, is going to be porting, polishing, and then reshaping each one of the intake and exhaust ports for the cylinder head. There's not really much that you can do down in the bottom end of the block other than replacing the pistons with forged components. So if you want to change the pistons, the rods, crank, all that stuff, if you can replace it with forged parts, you're going to have a much stronger engine that will be rated for much higher power. Once you have each one of these cylinders and the entire inside and outside of the block cleaned up and completely degreased, if you want, you can even go ahead and strip down some more dirt from the block. Now what I'm going to be using is a little bit of gasoline. It's a very safe, good way to clean all this stuff up because it's a solvent, and this is actually found inside the engine at almost all times. So if you just grab this and you go around each one of the cylinders, you'll be able to clean off and remove even more gunk. So that carbon buildup that's found on the top and also at the bottom, you can clean up using some gasoline. Now you might need to give it, a couple rubs and just clean it out, but you can see how dirty that is, and that's just from one cylinder. If you keep at this, you'll be able to make this perfectly clean. Once you're content with how clean the engine block is, you can go ahead and then protect each one of the sleeves by spraying a little bit of WD-40 down there, and it's going to prevent it from rusting. So on a completely aluminum block, you're going to have metal inserts found on the inside of each one of the bores for the pistons. So on each one of these are all made out of steel. So if you just leave them like this after you've completely cleaned them up and removed any oils from them, they are indeed going to begin to rust. So by spraying a little bit of WD-40 on a cloth and then wiping it down, you're going to have it so that there's going to be a slightly oily surface found on the top, and it's going to prevent it from rusting. Now you don't need to do that to the rest of the block because the block itself is made out of aluminum. However, it wouldn't be a half bad idea to do that to each one of the bores. Now, I'm going to keep on going one step further, and I'm going to completely strip down the block of all these imperfections, all the dirt, all the aluminum oxidization that's found on there. So this is eventually going to get painted, and it's going to look amazing. But what I'm first going to do is strip it down by sandblasting it, and then go from there. But I'm going to do that on a separate video because I've already gotten this video to be somewhat long.
Once the cylinder walls are coated in the WD-40, it should have a nice, clean, reflective finish, kind of like this. The WD-40 is going to prevent any rust and corrosion from happening on each one of the cylinder walls.
So after cleaning up the block, I went off camera and I spun the block upside down. Now when I did that, I noticed that something fell out of the block. And I was like, okay, what the heck is that? So I found this little piece of plastic right there. I found that, and it was lying in between one of these galleries that are found around the outside perimeter of the piston bores. So what is actually found out here is this is where all the coolant circulates. So all of this surface area, everything in there is where the coolant goes, and it cools down the engine. Now, what had happened before, and what I actually had problem with this engine before, there's a water pipe that's found on the back side of the motor, which is found back here, and it connects the thermostat to the coolant pump. Now, the water pipe that connects those two pieces together is made out of plastic, and it did break on me. So the components that were actually surrounding the outside perimeter down here broke off. And when I did a further inspection, I also found two more pieces of those same little plastic chunks. So if you guys have your engine block apart, this is a prime time to go ahead and inspect each one of the galleries found in here. So this here is where all the pistons go. This is where they go up and down. The outside perimeter of it here is where all the coolant circulates. And then all these darker areas that have oil stains on them is the oil parts. That's where the oil passages go through. Now, last but not least, we have this other passage right here, and this is where coolant goes through. So all of these other holes that you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 are where the head studs go onto. That right there is a pretty much rundown as to what you have found right here. Now you guys can go ahead one step further, clean this out, and I'm going to be sending this block out to a machine shop to get this full thing completely leveled out. As soon as you take the head off of the block, you should indeed be machining it every single time. Especially if you go ahead and you install those torque-to-yield bolts that are found right here, and then you drive the car and get it hot. 99 times out of 100, you are going to see some sort of distortion in the block and the head. So when you machine this down, you're going to be starting off with a brand new, perfect block. Now, before I go ahead and finish up this video, I want to show you another thing now that we have everything apart. So if you are curious and you want to rebuild your engine, more often than not, if you want to build it up to better specs, you'd be replacing your pistons, your connecting rod, and your crankshaft all with forged components. Now, those forged pieces are the same dimensions and the same size as the standard components that came with the engine, but instead of being made out of cast aluminum, they're made out of forged aluminum. So it's a much stronger piece. Now, once you have the engine completely apart, you can inspect to see if your components are indeed cast or if they're forged. With the internals of the engine removed, such as the pistons and the connecting rods, we can see if they're forged or cast. To do that, we're going to get a close-up of each one of these components. So we're going to take a look right now at the connecting rod, and you can see on the sides how there's some imperfections and irregularities in the metal. Now that means that this component is made out of cast aluminum. So the entire connecting rod was set inside of a casting, and then whatever areas that need to be machined were then machined to make it so that it would fit in our engine. It is going to be slightly more difficult to inspect the pistons, however, you still can see these imperfections. So if we take a closer look at the inside part of the piston, we can see that this section here, along with the entire internals of it down inside the piston itself, is all cast. On the outside, everything looks really nice, but we can take a closer look and we can see that this is also made out of cast aluminum by looking down here. We can also see on the connecting rod that this section here is all cast, along with the side parts right here. So you can see that this entire side was ground down and machined so that it would be a proper spec and would be a perfect match for the engine. The forged counterparts are going to look completely different than this. There's not going to be any kind of imperfection. Everything is going to look like it was perfectly designed and perfectly machined inside of a CNC machine. The same thing can be said for the crankshaft as well. You can see that each one of the counterweights and everything does have those same kind of casting imperfections and the irregularities, such as right here, as the pistons and the connecting rods do. So by looking at each one of these components, now that it's actually visible, we can see that this is made out of cast aluminum, these are made out of cast aluminum, along with these. There is a lot of good information found on vehicle forums. Sometimes these guys are absolutely brilliant, sometimes the information that they're telling you might not necessarily be true. But if you guys want to find out the best information possible, take a look at what you have or even pictures for yourself. because if you can see the actual part, you'll be able to determine whatever kind of condition that it's in, whether it be used, new, cast, or forged. The forged components that are going to be installed on this mini motor are going to be a lot stronger, and they're going to be also a little bit lighter. So I do have all those parts for the mini motor coming in. They are on their way. When I get them, I will be indeed showing you guys the difference between cast versus aluminum. The same thing kind of goes for cast wheels. They are nice, they are relatively cheap. However, if you want to get the best components possible, there is no question about it, forged is the best way to go. Now, as for this video, that is how you disassemble a complete lower engine block. So that is the short block right there. So everything that's found below the head gasket was removed in this video. If you're watching this video and you're not subscribed, what are you waiting for? Go ahead and click that subscribe button. My girlfriend said that every next 10,000 subscribers that I gain, we're gonna be going to a nice fancy restaurant and we're gonna celebrate. So if you guys wanna see me gain a couple pounds and have some good food, click the subscribe button, make my day, make our day, and you're gonna be one step closer to seeing this mini motor working. So I do have all those parts coming. It's gonna be awesome. Stay tuned. If you have any questions, throw them down in the comment section below, and I'd be more than happy to help. Again, guys, thanks for watching. I'll catch you in the next one. Peace.